How to relate to the presented prototype of the robot and what does it actually represent? At the very beginning of the event, a robot named Elon Bambalsi entered the stage. It was created by Tesla developers from available components in about 6 to 8 months. Interestingly, during the presentation, the robot walked on its own for the first time without any support or insurance. He moved slowly, danced a little for the audience, after which he turned around and, as you understand, left. Elon Musk said that the robot can do much more, and the company simply decided to avoid embarrassment on stage, as it was with broken glass. Therefore, further the robot's abilities were demonstrated on the screen. In the video, he was carrying boxes, watering liqueflowers, and moving parts at a Tesla factory under overhaul. In the video, one could see not only the movement of the robot, but also how it sees and perceives the world around it. The robot has hardware-level security gestures that are important for protecting both the robot and the people around it. The robot is only an experimental model for training. Close to the serial version of the robot Optimus was presented on stage a little later fully assembled, but not enough. The functional robot was mounted on a stand, although it could swing its arms and legs. Elon Musk noted that the company did not have time to prepare the robot for the presentation, and he will probably be able to walk and act at the level of Bambalsi in a few weeks. At the same time, in 5 years, the possibilities of Optimus will become incredible, and in 10 years, completely breathtaking. Musk is a well-known optimist. But still, let's take a closer look at what a Tesla bot is right now. It is known that the robot weighs 73 kilograms, is powered by a battery and a Tesla battery with a capacity of 2.1 kilowatt-hour, runs on a chipset and has the ability to connect to Wi-Fi. And it is interesting that in the battery on the block, all the electronics are integrated into a single printed circuit board inside the block. The robot's power consumption is 100 watts when sitting and 500 when walking. With this, the energy consumption should be enough for a whole day of work. Engineers designed the robot so that its mobility in the joints of the arms, legs and hands was as close as possible to a human. So the hands of the robot will repeat the structure of human hands, with the thumb opposed to them. The fingers are driven by metal tendons that are both flexible and strong. The robot has the ability to perform both wide grips of heavy objects, and delicately pick up something small and thin. Interestingly, like the Atlas robot, Optimus uses his arms to maintain his balance while walking. Of course, the linear actuators of the robot, which can lift a piano weighing half a ton, surprised. With such transfers of the Optimus, he will be able to lift weights as well as a person, and maybe even more. This is a real breakthrough for humanoid robots. With all this, the design of the robot is in a certain way limited by standardization. The designers created designs for each joint and then looked for common areas in each joint to limit themselves to using only 6 different actuators. At the presentation, it was emphasized that, keeping in mind the need for cheap mass production, engineers are trying to reduce the number of parts and energy consumption in each design element. As a result, today the robot has 28 structural drives. The number of degrees of freedom in the hands is unclear. So 27 degrees of freedom were declared, but on one of the slides their number is written as 11. Over 200 degrees of freedom are declared in the entire body of the robot. The Tesla Autopilot software has been ported from cars to Bluetooth and reconfigured to work in the new body and environment. As input, the system received videos of people performing real tasks, such as lifting boxes, and then, using inverse kinematics, it tried to make the Optimus robot repeat these movements. In parallel, so-called online motion adaptation was applied so that the robot could perform actions smoothly and taking into account the unstructured environment. The developers noted that in the end the robot will use hardware, autopilot and software for the platform's humanoids. The Tesla computer on board the robot will do everything a human brain does, namely process data and make separate decisions based on signals from multiple sensory inputs, as well as communicate via wireless communication. Optimus uses computer vision, receiving data from several cameras, including fisheye camera. It understands the world based on the three-dimensional presence of optical segmentation and color models, as well as using methods such as volumetric depths, visual navigation techniques, and others. Optimus has hardware-level security features to protect both the robot itself and people. Tesla already had emergency software for the car, and the company applied it to their robot. In the case of a car, he simulated collisions; in the case of a robot, his fall. As a result, when falling, the robot is so protected from damage that it can simply get up and continue to do its work in the future. According to Musk, the main difference between optimization and other humanitarian robots will be artificial intelligence, which allows them to navigate the world on their own, as well as large-scale production, which should reduce the cost of the robot to literally $20,000. And the cost of the robot follows that it is a very cheap labor force. It will pay for itself in 4 years at a cost of $1 per hour, with a 12-hour shift. To make the robot useful as quickly as possible and the engineers in the shortest possible time will try to adapt it to real tasks at Tesla factories. The timing of the start of production of the mask, as always, is optimistic and, from an outsider's point of view, is not very realistic. He hopes to start manufacturing robots as early as next year. We all remember the promise of autonomous cars in 2101, and the release of Cybertrucks in 21st. So feel free to add 5 or 6 years to the date. As always, Max is generous with promises and does not forget about humor. So he assures that Optimus will get conversational opportunities, as well as a lot of funny versions, for example, including a cat girl. We must always be careful not to go down the Terminator path, Musk added. We want it to be safe. In general, the presented robot is far from the smart universal humanoids, which today can only be seen in a science fiction film. But that was expected. Considering that about a year has passed since the start of development, and compared to the actor in the suit, Tesla has made good progress. Considering that the company is where it is today, thanks entirely to the sheer will of the mask, we would not write Elon off in the field of robotics. It will be a fundamental transformation of civilization, Musk said of his robot. And deep down we want to believe him. And you? Write in the comments. To other achievements of Tesla, to the disappointment of many fans of electric cars in the company. The date of the launch of the full-fledged function of the full autopilot has remained unnamed. This testing expanded in a year from 2 to 160,000 users, but remained at the level of beta testing. And although Musk, answering questions after the presentation, said that it would probably be deployed by the end of the year, these dates, as already happened, can be very arbitrary. Speaking of progress, so far the developers have noted that they have expanded the learning infrastructure by 40.6%, which has significantly improved the pace of development. The company trained over 75,000 neural network models during the year. This means that approximately one model is checked and tested every 8 minutes. Going into the details of the infrastructure a bit, Tesla notes that it maintains a cache of more than 14,000 GPUs for the learning process. Nearly 500,000 videos pass through the system every day, and so far almost 1,500,000,000 frames have been used to train the autonomous driving system. The entire training dataset now contains nearly 5 million clips. But in addition to video, the company generates a huge amount of simulation data, reconstructing real streets and intersections in it, for example, San Francisco. Tesla has also moved to an advanced dataset labeling system for system training. 5 million hours of manual marking are said to have been reduced to 12 hours of automated cluster work. The experts explained how, in certain situations where the camera image is ambiguous, the auto software uses additional frames to reconstruct the scene. As a result, the company hopes to create fully autonomous cars without adding new equipment. The company's engineers also spoke about the progress of their own Tesla supercomputer. So, the first supercomputer cluster will be completed by the first quarter of 2023. In total, the company plans to build 7 such clusters in Palo Alto. According to the company, a system with 10 cabinets will overcome the milestone of 1 exaflops. Increasing computing power should speed up the creation of both robotic and humanoid robots. Tesla is currently assembling 1 so-called tile per day with 25 chips on each. Thanks for watching, have a nice day and mood.